Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P0339 refers to an issue in the crankshaft position CKP sensor circuit that indicates intermittent interruption. The CKP sensor plays a crucial role in determining the position of the crankshaft, which is essential for engine timing. It is typically located near the engine's crankshaft, and its failure can lead to incorrect engine timing, resulting in engine stalling or failure to start. The error highlights the need for careful diagnosis and repair, as it may lead to further engine performance issues if not addressed. Before beginning troubleshooting for this DTC, it is recommended to record all freeze frame data and any onboard snapshots. This information can provide valuable insight into the conditions that led to the code being set. DTC P0339 indicates a malfunction within the crankshaft position CKP sensor circuit. The CKP sensor's primary function is to monitor the position and rotational speed of the crankshaft, sending this information to the Engine Control Module ECM or Powertrain Control Module PCM. It's typically mounted on the engine block or timing cover, depending on the engine design. A proper functioning CKP sensor is vital for engine timing, as it helps manage ignition and fuel injection timing. If this sensor fails or has an intermittent electrical issue, it can result in poor engine performance and stalling. Recognizing the precise location and understanding its role is key in diagnosing the problem accurately. Various factors can lead to the occurrence of DTC P0339. One common cause is poor electrical connections or loose terminals between the CKP sensor and the ECM PCM. Deterioration or wear of these connections can lead to inconsistent sensor readings. Another potential issue is damage to the CKP pulse plate, which is essential for the smooth operation of the CKP sensor. This damage can disrupt the signal being sent to the ECM, leading to inaccurate timing. Lastly, a faulty CKP sensor itself may be the culprit, as internal failures can render it incapable of sending the correct position signals. Identifying these potential causes is crucial for an effective troubleshooting process. When DTC P0339 is triggered, several symptoms might manifest. One of the most noticeable is engine stalling, which occurs when the crankshaft position data is not accurately relayed, impacting the engine's ability to maintain proper timing. Drivers may also experience difficulty starting the engine, resulting from misfires or improper ignition timing adjustments. Additionally, the engine may idle roughly, which can be felt as shaking or vibrations while stopped. It is essential to observe these symptoms closely, as they provide significant clues about the underlying issue related to the CKP sensor malfunction. Addressing these problems promptly can help prevent more severe engine issues down the line. To begin troubleshooting DTC P0339, first, turn the ignition switch to the on position. 2. Without starting the engine. This action provides power to the vehicle's electrical components. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs. Clearing the codes allows for a fresh start in diagnosing any current issues. After clearing the codes, start the engine and let it idle for approximately 10 seconds. This idling period ensures the engine reaches baseline operation, providing an essential context for subsequent data readings. Always remember to perform these steps carefully to avoid any inadvertent errors. After starting the engine and allowing it to idle, the next step is to check the CKP noise in the data list using the HDS. This reading will indicate counts of noise from the CKP sensor. If 0 counts are indicated, it suggests that the circuit is stable at that moment. leading you to continue with further diagnostics outlined in Step 8. Conversely, if the counts are not zero, it signifies a potential intermittent failure in the signal transmission or another underlying issue. Understanding the significance of these readings is vital, as they inform your path forward in troubleshooting the DTC effectively. In Step 3, it is crucial to perform a test drive of the vehicle, focusing on the parameters indicated in the previously recorded freeze frame data. This includes monitoring the engine speed and vehicle speed sensor (VSS) data during the drive. Observing how the sensor and vehicle interact in real time will provide additional insights into the CKP sensor's functionality. During the drive, ensure that all systems are operating within their normal parameters as noted in the freeze frame data. Analyzing these aspects helps to replicate conditions leading to the DTC, thereby improving diagnostics. After the drive, further readings will help confirm or rule out specific causes. After the test drive, it's time to check the CKP noise again using the HDS. Just like before, you need to see if zero counts are indicated. If the counts are found to be zero, you can conclude that there are no current issues with the CKP sensor circuit, prompting a shift to Step 8 for connection checks. However, if the counts are not zero, it points toward an intermittent failure, suggesting that while the system may seem okay at the moment, further issues might arise. At this point, it's essential to inspect for poor connections or loose terminals located at the CKP sensor and the ECM-PCM. These connections can sometimes be a source of erratic signals, which may not always present themselves consistently. For Step 5, first turn the ignition switch to the lock position, 0. This action powers down the vehicle's electronics, allowing for safe inspection of electrical components. You'll then inspect the connections at the CKP sensor closely. Verify that there is no corrosion, damage, or loose terminals, as these factors can contribute significantly to issues indicated by DTC P0339. Equally important is checking the connections at the ECM-PCM. Any discrepancies here could lead to interruptions in the signals received from the CKP sensor, causing the error code to occur. Careful inspection can prevent the need for more extensive repairs by identifying simple connectivity issues that can be resolved easily. In this step, you will examine the engine ground and body ground connections as well. Poor grounding can lead to erratic or insufficient signals sent from the CKP sensor to the ECM/PCM. A good ground is crucial because it completes the electrical circuit, allowing the various components of the system to communicate effectively. During your inspection, make sure that these connections are clean, tight, and free from corrosion. If you find any damaged or loose connections, repairs or replacements will be necessary. After verifying that these ground connections are satisfactory, you can proceed to Step 9 for further troubleshooting based on what you find. Step 7 involves removing the oil pan to access the CKP pulse plate directly. The pulse plate is essential for the CKP sensor to function, as it provides the necessary signals that the ECM-PCM interprets for engine timing. Upon removing the oil pan, carefully check for any visible damage to the pulse plate. If it is damaged, a replacement will be necessary, as this is crucial for the CKP sensor's operation. If the pulse plate is undamaged, you will continue with Step 10 to check the CKP sensor itself. It's important to handle the components with care to avoid causing additional damage during your inspection. If you determine that the KP pulse plate is indeed damaged in Step 7, then the next course of action is to replace it. An intact CKP pulse plate is vital for sending accurate position signals to the ECM-PCM. After replacing the pulse plate, be sure to proceed to the next troubleshooting step, which involves examining the CKP sensor itself. Completing these steps will help ensure that the circuit is properly configured, preventing future interruptions. Once this is done, you can move on to Step 11 to reset the system and validate your repairs successfully. If the CKP pulse plate was found to be undamaged in Step 8, then the next troubleshooting step is to replace the CKP sensor. A faulty sensor may not adequately send the required signals to the ECM/PCM, leading to engine performance problems as indicated by DTC P0339. After replacing the CKP sensor, it's crucial to proceed to the steps that follow for resetting the ECM and revisiting system checks. Replacing the sensor should resolve the immediate issue, but it is necessary to confirm functionality before declaring the repair complete. You will next turn the ignition back on and prepare for the reset process. In Step 10, turn the ignition switch to the on position 2, once more, to power up the vehicle's electronic systems. Utilizing the HDS, reset the engine control module ECM or powertrain control module PCM. This reset clears any previous fault codes and allows the system to recognize any new changes, such as replacement components. Following the reset, it is vital to perform the ECM/PCM idle learn procedure, which helps the system relearn optimal operating parameters for smooth engine idling. These steps are essential for ensuring that all adjustments are taken into account, facilitating accurate vehicle performance moving forward. After completing these, check the system for any new DTCs before proceeding. In Step 11, the next action involves performing the CKP pattern learn procedure. This procedure helps the ECM learn the new CKP sensor signals after replacement. Start the engine and let it idle for about 10 seconds to allow the system to gather data and establish a baseline for the CKP sensor readings. After the idling period, use the HDS to check for any pending or confirmed DTCs. If DTC P0339 is indicated again, it reinforces that the issue persists, and you should return to Step 1 for a thorough review of connections and terminals. Conversely, if no DTCs are present, it signifies successful troubleshooting and repair of the CKP sensor circuit. After following through each step in the troubleshooting guide, it's imperative to verify that the repair was successful. Start by checking for any Diagnostic Trouble Codes, DTCs, using the HDS. It's essential to ensure that none of the initial codes, including DTC P0339, are present, which would indicate unresolved issues. Additionally, go over all connections to confirm that they are secure, with no loose or corroded terminals that might cause future problems. Finally, confirm that the symptoms that were present before repairs, such as engine stalling or rough idling, have been resolved. A successful verification ensures that the problem has been effectively addressed, allowing the vehicle to perform optimally to prevent future occurrences of DTC P0339 and other related issues. Implementing regular preventive maintenance is key. Schedule periodic inspections of the CKP sensor connections, including checking for corrosion and ensuring that terminals are tight. It's also crucial to check ground points regularly, as poor grounding can lead to erratic sensor signals. Additionally, maintaining the cleanliness of the CKP sensor and its components can prevent debris from affecting its performance. By adopting these preventive measures, you can help sustain optimal engine performance, extend the life of the CKP sensor, and reduce the likelihood of running into electrical issues down the line. Regular upkeep contributes to more dependable vehicle operation. In conclusion, understanding the role of the CKP sensor and the implications of DTC P0339 is essential for effective vehicle maintenance. Recognizing the symptoms early, such as engine stalls or rough idling, can prompt timely troubleshooting and prevent further issues from escalating. Following the outlined diagnostic steps carefully ensures that you systematically address the root cause of the problem. From checking electrical connections to performing necessary replacements, each step plays a critical role in resolving CKP sensor circuit issues. Lastly, engaging in regular preventive maintenance practices can save time and resources in the long run, keeping your Honda Civic running smoothly and efficiently. Please like and subscribe to the channel. See you next time.